All right, hello everyone. I hope second day is going well for everyone here. My name is Ahmad Danesh. I'm the Associate VP of Product Management at Astera Labs. I run our product management, product strategy team. Feel free to, during this event, ask any questions you have, find me after. I'm happy to expand a little bit further as well. What I wanted to talk to you today is about how Astera Labs is enabling unprecedented scale for cloud and AI infrastructure. So I'll start off with a little bit about Astera Labs, and then walk through a little bit about our products and some of the demos that we're showcasing today in close partnership with some of the leading hyperscale and cloud providers. Our mission is to provide connectivity solutions for cloud and AI infrastructure. When I talk about connectivity, when we talk about AI, we're looking at unlocking a lot of the memory, a lot of the I/O, and unlocking a lot of performance capabilities by connecting the big AI accelerators together, connecting the NICs together, connecting the CPUs. At Astera Labs, we're just trying to connect all those pieces together, unlock the performance bottlenecks so that we can develop the next generation of cloud servers. Astera Labs, we were founded about 6 years ago, coming up on 6 years in a couple weeks. Pretty excited to celebrate that as well. Scaling quite rapidly. We're just over 200 employees right now and 6 headquarters. When we talk about AI infrastructure, we're really looking at 3 main protocols that move data throughout the data center. You have PCIe, you have CXL, and you have Ethernet. And we have solutions there to really unlock the performance across all 3 of them. Let's take a look at some of the actual architectures and where PCIe and CXL and Ethernet are being used today. On the far left there, what you're seeing is a lot of the GPU and accelerators. Of course, there's the back-end GPU to GPU fabric connectivity, whether that's going to be PCIe, CXL, Ethernet, and in some cases, of course, there's some proprietary protocols that are used today. It's really important to get the maximum bandwidth, the maximum performance, as well as the lowest latency solution. So we have PCIe and CXL retimers to really be able to unlock the performance there, getting the maximum bandwidth that you can, and especially with CXL being a memory semantic protocol, having low latency connectivity so that you can get to that low latency memory access that's needed for that. We also have CXL memory controllers that increase memory bandwidth and capacity, so that as we take a look at AI models and the big memory wall that we're hitting with the model sizes increasing, the computing power increasing significantly faster than the actual memory bandwidth, we have CXL devices to really unlock the performance that's needed there. And then, of course, once we start then scaling this out and you want to create larger and larger fabrics and parallel processing accelerators, you need to use Ethernet to get across that larger scale. So we have PCIe, CXL, and Ethernet really fundamentally solving all 3 of those key applications. So what are we showcasing at OCP? A few key announcements. As we take a look at PCIe expanding out, PCIe was started off as being an inside the server connectivity, right? As we start seeing this scale and this need for disaggregation and parallel processing, we start to see PCIe being cabled at a rack level. In the future, we'll also see it going from rack to rack as well. And so what we're showcasing here is how our PCIe and CXL retimers are enabling long-reach PCIe cabling solutions to develop parallel processing AI accelerators, as well as CXL disaggregation for memory pooling and memory fabric solutions in the future. With CXL, what we've done is we've developed multiple different use cases using our Leo memory connectivity solution, where we're delivering unprecedented capacity as well as unprecedented memory bandwidth for some major AI, HPC, and other memory-intensive workloads. We'll walk through a little bit more detail in this architecture in a few slides as well. And finally, with Ethernet, where we're delivering unprecedented flexibility depending on the types of cables that you want to be able to use in the system for switch to NIC, switch to switch, and switch to accelerator connectivity, where depending on if you're looking for maximum performance, you're looking for redundancy, you're looking for gearboxing and speed matching capabilities, our retimers and active electrical cable solutions can be used in all 4 of those all 3 of those use cases. So what do the products actually look like? We have on the far left there our PCIe and CXL smart retimers. These comes in a few different flavors, whether you want by 8 or by 16 connectivity. The board that you see there is actually a development platform for our customers where the customers really want to be able to hit the ground running really fast. They get to develop their solutions using that. And then we have active electrical cable type of solutions that are being developed as well. In the middle, we have our Leo CXL memory connectivity platform that's delivering that unprecedented capacity and bandwidth that I referred to, as well as our Aurora cards, which deliver a really seamless way to be able to plug and play and deploy memory seamlessly within a server using an add-in card form factor. And finally, on the far right there, you see our Ethernet Taurus smart cable modules. What's unique about these modules is rather than having a single silicon that you take and develop into a module, we'll actually deliver that module to the cable vendors, who will then integrate it into their cables. What that provides as flexibility is that you now get to actually only validate one paddle card. You're talking to an electrical interface with the same telemetry management capabilities, and then you get to go and get that flexible supply chain from a number of cable vendors. And on the bottom right there, what you can see is an actual test platform that we enable for our cable vendors so that they can actually get the high volume production very quickly and be able to connect a lot of different types of connectors as well as different types of cables with a single test platform for high volume production. So let's walk into a little bit more detail on on PCIe and CXL cabling and how it is today and how it's going to be looked at in the future. On the far left-hand side here, you see your typical converged AI infrastructure or even general purpose servers where a lot of the components are interconnected within a single server. What we're transitioning to, because that far left is a static configuration that doesn't scale very well. With an adaptive environment that's disaggregated AI infrastructure, we can actually cable these solutions together and develop a lot lower power consumption, better cooling that's targeted for those particular applications. And of course, we hear a lot at OCP today that's talking about liquid cooling. You can develop those solutions that are really targeted for that application. What we can deliver with PCIe and CXL is up to 3 meters of cabling today. And that's really the need that's being driven is about in the range of 3 meters. What we're going to see in the future as we go beyond a rack, and we want to get rack-to-rack connectivity, that need's going to change, and our PCIe retimers are already able to deliver that higher reach if needed. Now let's take a look at memory. This is probably one of the biggest conversations that's been at the show the last couple days is how do we optimize TCO for whether it's in-memory database, AI infrastructure using CXL. When you take a look at the solution on the left there, that's pretty much what has always been the solution if you wanted to increase memory. If you want to increase memory, add more CPUs, add more servers. Not the most efficient way to do it if your application is memory intensive, meaning you don't need as many CPU cycles, you don't need as many GPU cycles to do so, you just need a lot more memory and memory bandwidth or memory capacity to do so. This we can get up to the solution towards the right where we're actually just adding CXL memory controllers to an existing platform and really delivering unprecedented memory density with that solution. So the far right-hand solution that you have there, that's actually done in partnership with AMD and Lenovo, where using their SR65 V3 platform, where you have 8 of our Leo controllers delivering 32 additional DIMMs beyond the local CPU attached memory. So some serious power-hungry systems here, delivering a lot of capacity for those big databases. And this then gets extended towards AI applications such as vector databases that are needed for AI inferencing. Next, as we take a look at our Taurus solutions, what this is really addressing is the translation as we go into higher and higher Ethernet rates, getting up to 100G per lane, 800G total bandwidth. Passive cables are starting to become a challenge in terms of cable management, in terms of the thickness of the cables, and how to be able to actually route these within the rack. So what we allow is extending that reach even further so you can actually parallelize more equipment. You also get thinner cables to actually reduce the cost and be able to manage those cables more effectively. And by having an active cable, you also get a few additional advantages where you can actually now quickly deploy these things. You get a lot of diagnostics. You also get gearboxing capabilities where you have more flexibility to be able to connect from a device that might only be 100G per lane to something that's a bit older that might only be 50G per lane. These active components can now actually do that translation for you. And then deploying these things really quickly requires you to have these really good test platforms to do so. So we also enable those test platforms for our customers to deploy very quickly into the market. There were quite a number of presentations that you might have seen from Astera Labs over the last couple of days here so far. I think there's 2 more left that we'll be doing. And please do visit us at our booth just over there in the corner at booth A11, where we're showcasing all the demos that I just described today. I do have a few minutes left if anyone has any questions, and you can also find me out after if you have any more. All right, well, thank you very much for your time.